Let us learn the next chemical property, that is reaction with the oxygen. So reaction with oxygen. So group 15 elements react with oxygen to produce the oxides. So formation of oxides are there. Then the type of oxides are actually E2O3 and E2O5. So two types of oxides are forming, that is E2O3 and E2O5. Here E represents these group 15 elements. Then what is the acidic character of these oxides? What is the acidic character of these oxides? What is the trend in this group? So the trend is actually it decreases down the group. So the acidic character decreases down the group. The reason is the non-metal oxides are acidic and metal oxides are basic in nature. So we know that these two are non-metals, they are strongly acidic oxides. So these two elements, nitrogen and phosphorus, they are non-metals. Non-metal oxides are acidic in nature. So these are acidic oxides. Then actually the acidic character decreases down the group, and this is weakly acidic oxide. Then this one is amphoteric oxide. That means that shows both the property of acid and base. So this is amphoteric oxide, and bismuth is a metal. So this is a basic oxide. So metal oxides are basic in nature. So bismuth produces, or bismuth forms a basic oxide. So the acidic character, the acidic nature of these oxides decreases down the group. Then comes the next point, that is the oxides of higher oxidation state of the element is more acidic than that of lower oxidation state. So the same element having the oxides, nitrogen with different oxides, N2O, NO, N2O3, N2O4 and N2O5. These are different oxides of the same element nitrogen. So let us see what is the oxidation state of this element nitrogen. So in this case, you know, oxygen is -2, so this will be +1. So 2 into 1, 2, and this will be -2. Both gives 0. So it will be a neutral. So let us check the neutral oxidizing property or the oxidation state here. In this case it will be +2, it will be +3 in N2O3, here it is +4, and here it will be +5. So when you check the oxidation state of nitrogen, we can see that in this case it will be increasing. So +1, +2, +3, +4 and +5 is the oxidation state of the same element nitrogen in the case of these oxides. So we can say N2O5, this oxide is having more acidic character since nitrogen is having the higher oxidation state. That is the point. So this is about the oxides of these group 15 elements. Let us see the third chemical property. The third chemical property is reaction with a halogen. Reaction with a halogen. Group 15 elements react with a halogen to form halides. So halides are formed when group 15 elements react with a halogen. So the first point is trihalides of nitrogen are not stable except NF3. So trihalides are not possible. So actually these halides are formed of the type MX3 and MX5. So two types of halides can be formed. One is MX3 and MX5. Here M represents these elements. So trihalides of N. So nitrogen will not form trihalides of the type MX3. It is not stable. They are not stable except NF3. So NF3 is possible, but NCl3 or NBr3 or Ni3. So these are not stable. So the reason is there is a weak bond between nitrogen and these halogen. So chlorine, bromine, iodine with nitrogen forming a weak bond. So this will not be possible. But the only possibility is NF3. So the next point is pentahalides of nitrogen will not exist. Pentahalides will not exist. That means MX5 type. So MX5 means pentahalides. So pentahalides of nitrogen will not exist. Nitrogen pentahalide form ചെയ്യുന്നില്ല. So അതിന് കാരണം the reason is the absence of vacant d orbitals in the case of nitrogen. In the case of nitrogen, there is no vacant d orbitals. So we know that in nitrogen, the electronic configuration is the outer shell is having 2s2, 2p3 configuration. There is no vacant d orbital. But in the case of PCl5, so PCl5 will exist but NCl5 will not. That is a question. Here PCl5 will exist. The second one, that is phosphorus. Phosphorus will form pentahalides, but nitrogen will not form pentahalides. What is the reason? So in the case of phosphorus, there is 3s2, 3p3 configuration in the valence shell. So there is a possibility of d orbitals or vacant d orbital is there. So in the case of p ground state, the electronic configuration is 3s2, 3p3. So the orbital diagram will be, this is 3s2 and this will be 3p3. So this is the orbital diagram. In the case of excited state, p excited, there will be, so one s electron will be excited to the 3d level. That means there is vacant d orbitals. So this is vacant d orbitals. So this will be excited. So 3s orbital will be excited. The electrons in the 3s orbital will be excited to the 3d level. So there is one electron is excited from s level to d level since there is vacant d orbital. So in the case of phosphorus, there is vacant d orbitals. So there is an excitation. So the s electrons are excited to the d level. So 1, 2, 3, 4, 5. Then the oxidation state will be +5. So there is a possibility of oxidation state of +5 in the case of phosphorus. So PCl5 will exist but NCl5 will not exist. So N is having 2s2, 2p3 configuration. There is no vacant d orbital. In the case of phosphorus, there is 3s2, 3p3 configuration. So vacant d orbital is present. That is the reason. So this is about halides of group 15 elements. So the fourth property is reaction with the metals. So all these elements, all group 15 elements react with the metal to form their binary compounds, exhibiting -3 oxidation state. That is an important point. So -3 oxidation state is showing by these elements in group 15. So examples are calcium nitride, calcium phosphide, sodium arsenide, zinc antimonide, magnesium bismuthide. In all these cases, you can see the oxidation state of these group 15 elements will be -3. So the -3 oxidation state is exhibiting by group 15 elements in the case of their reaction with the metals. So this is about the chemical properties of group 15 elements.